This series on women in science, technology, and business is brought to you by Zoho Corporation. Zoho is the operating system for business.
Hello, I'm Kamla. My guest today is Nancy Zayed. She is the co-founder and chief technology officer of MagicCube, a digital transaction security company based right here in Silicon Valley. Nancy has worked at Apple, Palm, Cisco, and other Silicon Valley-based companies. And at Apple, she worked at a product that we've all used, at least here in the studio, Final Cut Pro. So welcome to the show.
Thanks for having me.
Final Cut Pro, we have all used it.
Yeah, it's a wonderful application.
Did you use it too?
I did.
So you,
I did. We have to.
You have to?
Yes.
Okay. Do you still use an Apple computer?
I have never switched.
You mean?
Ever.
You started off with Apple?
Started with Apple, tried Windows for 6 months to really give it a shot, and I was like, never, ever again.
So you're an Apple household?
I am, yeah.
Okay. So you are now the co-founder and chief technology officer of MagicCube. Who came up with the name?
I can't remember, but I know that we were looking, we as in myself and my co-founder, and we kept looking at the architecture, about the aspects, what we're protecting, what we're creating, and you know, and we started building walls. You know, so we're protecting it. Here's the wall that protects blah blah blah, and so on. And before we knew it, it was like that looks like a cube. So it's a magical cube.
Because when you think of MagicCube, you think of Rubik's Cube.
Funny you should mention it. That's also part of the design that we have. So it really is more than just a form. It really is about building protection walls that are intelligent and can look at the attacks in different ways, and hence, yes.
So it is malleable, can be reconfigured.
That is
and
absolutely
can be
true.
On the fly reconfigured?
It can be. We're going to have to sign an NDA here.
Okay, no, this is Silicon Valley, so you know they drop NDA. Anyway, what does MagicCube do?
MagicCube makes security easy for mobile and IoT applications.
IoT stands for Internet of Things.
Internet of Things. So, billions and billions of devices that are becoming smarter enter the network. And the network can no longer defend, against all types of attacks, and the devices are different. So what we came up with is a technology, a platform technology that abstracts all the different nuances of a platform and presents the host application with a simple API, so that they can do whatever they want to do with their business logic. And once there is sensitive logic or sensitive data, that's when we come up through an API, do our thing, clean up, and go.
So you're a software-based solution then?
Yes. So we are, you can think, for the lack of a better term, you can think of us as some form of a virtual container that lives in the memory of the application that's dealing with sensitive data and logic. Think payments, think healthcare, think multiple other cars. So these are critical applications that require protection, and basically we make sure that these applications are not at the mercy of hardware, whether it's there or not, and the complexity. So we literally give you a virtual chip, that is dedicated for your logic, dedicated for your data, and simplify the world for you, and you can move on to other devices.
So another way of thinking is this is a MagicCube that's there for every application.
Yes.
And then it can protect that application from whatever intrusions or phishing.
Yes.
Where the data is trying to be, where they're trying to compromise data.
Right.
Any kind of hack, any kind of DDoS attack, anything that you can think of, where there is war, actually.
Yeah, well, exactly. So, typically current security solutions are kind of reactive. We take a proactive approach. So it is not.
So reactive is once the software has started executing on something you can't do. Only then
once
can
you've
it come.
Been yeah, exactly. So once you've been.
You're saying that we'd come before.
Yes,
we
exactly.
come before. Because software does not know how sensitive or complex data is. When I use the phone, and I send, if I'm doing a transaction, you don't know how important that transaction, whether it's a bank transaction, whether it's an Amazon transaction, or whether it's a WhatsApp transaction. I don't know. So data, software cannot recognize the data, how sensitive the data is. And is that why you're using a software-based solution? I'm trying to understand why you're using a software-based solution for security purposes.
We're using software because it's more ubiquitous. You have more control over it. Hardware by design or by nature is very static.
It's hardwired.
Yes, it's hardwired. And any changes in it is a big chain of events that have to happen until you get that change, if at all, right? So, and software is the exact opposite. You have absolute control over it. You can modify it more simplistically than you can ever do for hardware. There are no, the ubiquity of software, because hardware, if you depend on it, it can exist on one platform, but not the other. And then you inherit that complexity, and then you have to develop for this and develop for that, and before you know it, you have a very complex condition, of software is in a complex condition. And that's actually one of the reasons software, or one of the ways software get breached. It's when it becomes overly complex. That's when there are gaps that can be found as hackers try to, reverse engineer and try to understand the different pieces in it.
I read somewhere that bugs is one main reason why there are security breaches. Is that something that you've come across?
No, not really.
No?
I mean, well, bugs, okay, so a security breach happens because of a bug. The nature of the bug, is different. Now, security protocols and concepts and so on, there's an abundance of it. The bugs always happen, either at a design level or at an implementation level. That's the bug. So yes, you're right. Breaches happen as a result of bugs. Just exactly where the bug is, that's always the place of investigation.
I believe there's application security and software security.
Okay.
Is there a difference between the two? Are they the same? Because, there are so many terminologies when you navigate the software world today. I don't know, is there a standard that is?
No, standard, okay. Are you kidding?
So there's no standard?
Not really. Software is an umbrella. Application is a subset of, is a type of software. Drivers is are another set of software. So it's just the big industry is called software industry. What kind of software is running in it? Could be application, or it could be a service, a web service. All of that is called software.
So how did you all come up with the idea to start a company? Because you had worked for all the big companies here. And then usually people do a startup either when they're fresh out of college.
That's true.
Or maybe 5-10 years after that. Not after having spent all this time that you've done. So I'm just curious, because what gave you the courage to do a startup? Because they're never easy.
No, they're not. They're not for the faint of heart, but they're a lot of fun. So people should never be afraid of doing their own startups.
This is true, but it takes a toll on families, which is the untold story of Silicon Valley. It's how the family ends up paying a price for it.
Absolutely.
Because this is a beast that takes over your life.
It does.
If there's a bug, you spend the next 36 hours trying to figure out what that bug is. So everything looks hunky-dory.
If you're lucky, 36 hours if you're lucky.
But the point I'm getting at is that people think it's very sexy to do a startup, but it's a lot of hard work, a lot of dedication, and it takes a toll on family.
That is true.
So that's where I'm coming from when I ask you this question, not because, so I'm trying to understand what prompted you and your husband to start the company.
Not one factor.
Okay.
There are like many. It's almost like star alignment. Like many factors came into play at the same time, and suddenly that time became the right time. But before we get into how we started that, but generally startups, before you jump into it, everybody needs to understand what that means. Yes, there's a toll in the family, financial toll, and even relationship tolls and all of that. So no one should jump into a startup until they have figured out their support system, right? Until their significant
Sometimes
other.
they don't have.
That's a tough. This I don't know. It's a case-by-case basis. But going to how we decided to start that. At the time, I was doing some grad work. You know, I was just graduating, and I was doing.
Oh, you went back to school?
I did. Yes. Yes.
Oh, so that's when you did Carnegie Mellon.
Yes.
Okay.
Yes, actually, and my daughter was graduating from high school and going to college, and I was graduating from grad school. So, so both, you know, it was nice.
You're all students.
Yes, we were all students, and went to grad school even late in career, right? But nothing. It is never too late for anything, which takes us to the next part. So as I was, I was doing some practicum work with a big hospital, and I was looking at the medical devices, and I was looking at, you know, the software that runs on it, and it dawned on me that the security of the medical devices, they seem to be inheriting a lot of, you know, concepts when they don't really apply, you know. They might not one-to-one apply. Anyway, and at that time also, my co-founder, my husband, was working in a big payment company. And,
where security and trust is important.
Well, yes, exactly. So they were trying to solve a problem. And he and I have been each other's coach for all of our lives. And he goes, oh, we're going to do this and that and the other thing. And, you know, and I'm going, no, I don't think so. I think it needs to be done that way. And then he goes, no, everybody said it's not possible. So we went about our merry way. And I was like, I like that. I like this challenge. It is meaningful.
So you like challenges?
Yeah, well, yes.
Well, okay.
Yes. So, you know, it's like all of what I studied, all what I learned says that it should be possible, right? Difficult, but it should be possible. So I was working on it, you know, and so on. And then he left, and I was working on it, trying to prove this. And oh my God, it actually started, you know, showing some results. So we were like, there it is. And at that time, we were, you know, our kids are growing up and they're going to college, so we were empty nesters. So, you know, so what I'm talking about, like alignment, suddenly we have the bandwidth, the time, the experience, and, you know, to try something that we believe in, that actually something that adds value, something important, which is something that we all probably look for in our careers toward the end of or as we mature in our careers, we look for meaning, legacy. And so this was the genesis of MagicCube.
So you came up with a solution that convinced
Yes.
your husband that there is a prototype?
Yes.
Did you build a prototype?
I did, a pre-prototype.
Okay.
So I built a pre-prototype.
Do you code?
I do.
Oh, you code, okay.
Up till today, you know. And
So you're not a hands-off person?
no.
Okay. And you learn new languages every time?
Yes, yeah. Well, yes and no. I mean, once you have solid foundation in software engineering and programming, and you pick a really mature language and you learn it, and the rest comes kind of easy.
But I've heard from people who have learned software the old way, the Unix and the mainframe era, where
Yeah.
it was far more rigorous.
Yeah.
They seem to have a hard time learning the new languages because they say that it's not very clear how to code in these newer languages. So that's the other side that I've heard from some people. Because they're very rigorous.
Okay, new languages do a lot for you that otherwise you would have had to build it yourself.
Gotcha.
Okay, so that's probably the aspect of difficulty. Some engineers who are used to, you know, the way that you just described, they are used to doing every single thing for themselves. So they are in 100% control. As language is progressing,
they're not used to working with libraries.
Or they create their own libraries. Maybe they're not used to what the compilers and the linkers and the modern, you know, will do, that can do for you. So it becomes a bit more, and the framework, so it becomes a bit more, it's like, who did that? Why should I? Why am I not in control?
Have you struggled learning a new language?
I can't say I have struggled, but I have made decisions that I don't like that language now that I say it, and I want to stick with that other language.
Gotcha.
So that's.
So you go and test it out and see which is the one that works for you.
Yes.
Okay.
Not every language is suitable for every implementation or for every application. So some languages lend themselves more natural to the use case that they're going to solve, or to the problem that they're going to solve. Others don't. So you need to be able to pick the right one.
Okay, so we went off track. So you and your husband, there you were talking, and you came up with a pre-prototype,
Yes.
and then he said, okay, we can run with it?
Yes. He
And then-
goes, I can get funding for this.
Oh.
Yes.
So you got funding?
Yes. So
And this was in?
That was fall of 2014, I would say.
Okay.
Yes, fall of 2014, I was like, okay, this will work. And he was like, let me worry about the business, about the funding.
Does he code?
No.
Okay, so you're the coder.
Yes.
Okay, that's why you're the CTO. Okay, so how much funding did you get the first time?
Well, we got angel funding, and in all honesty, the numbers keep changing, so I can't. But you know, we got seed funded, and then we went for recently our A round, and which is I don't know what's the statistics. 1 out of 100 gets funded of startups, and then I don't know 1 out of what makes it after that. But anyway.
So you got your
yes.
A series too.
Yes.
Okay,
yes.
And how much is that? Can you share?
No.
Again, the NDA kicks in.
Yeah, I actually, this is part of how we work together in our startup. There's a very clear set of responsibilities. So as long as I'm wearing the CTO hat and not necessarily the co-founder, then these are the topics that I same thing. He's the business, so he will never architect or re-architect behind my back.
So you're the software architect.
Yes.
Okay,
yes.
and but even as a CTO, you would know how much you got.
Of course, of course. But
So does that mean because you got a second round of funding, that means you've now got a viable product?
Absolutely.
Okay, and you have clients?
We do.
Okay.
Yes.
So the product is used by enterprises, not by a individual user.
The individual user is not supposed to feel it. So
Okay.
it's a B2B2C. So
Okay.
essentially our partner or our customer is a huge enterprise that has a mobile presence and mobile services on phones or on smart devices, and they have millions of users.
So take a bank.
Yeah, as a bank,
So I have a bank app.
Mm-hmm.
So your software would be deployed when I
Yes.
use the app.
Yes, exactly.
So this is per app.
Per app.
Okay.
Yes.
So if the bank has 3 apps, there'll be 3 deployments
Yes.
of MagicCube.
Yes.
Okay.
Yes.
And those 3 apps would be different.
They will be different.
So does that mean that the MagicCube's solution would also be different for each app?
They will be at the basic platform. They're largely the same, but at the area where the apps are different, a portion of it will be different.
So will it work for Apple phones, Google, everything?
Everything.
Okay. So you work with Unix and Linux.
Anything that is Unix or a Unix variant.
So Mac is
something.
Mac
Yes,
is Unix.
yes,
Okay.
yes.
Who do you know? So Windows, you probably don't work with Windows.
No.
Okay, so that's why. And what languages do you use for your coding?
C and C++.
So the old language. Okay, the robust old language. Okay.
The good old C and C++.
Okay, so that's what you use.
Yes.
And okay, so this is very interesting. So I guess there's a different way of describing what you've done. And I guess you are a software container that lives inside an app.
Yes.
But that container could be punctured. There could be holes created in that container. How do you handle that?
Well,
I'm just being the devil's advocate.
No, this is I play that role in there. You know, like in the engine room.
When you're stress testing.
Yes,
okay.
It was stress testing and so on. We will know.
You will know.
Right.
Okay.
So we will know, and we will act accordingly.
Okay.
So yeah.
Okay. How did you get interested in math and science?
3rd grade. Things started making sense or explain, you know. It's like suddenly when somebody teaches you something and then it explains something that you never understood.
Was it math or science?
It was science.
And do you remember the teacher?
Yes, I do. I actually do remember the teacher.
What was her name?
Miss Zayed. So I remember, you know, and this is why teachers, like they are they are the angels. Some of them, they will make the difference, absolute difference, you know, to the child as they grow. I know that she explained heat. And the effect of heat on metals and liquids, and then showed us an experiment, and it just made sense. And I liked the feeling of it makes sense. So I associated science with making sense.
And that's what...
and since then, yes.
But your father was a doctor,
Yeah.
your mother was a pharmacist, so
Yes.
science was already in the air.
Yes.
And you
All
wanted
the
to become a
time.
doctor.
I did want to become a doctor, and then I kind of chickened out of it because of having to deal with, you know, being a doctor. And then I was like, okay, there is this new thing that's coming up, which is the technology part, and that's how I got interested, because you can, through technology, you can expand into medical, and you can expand into many
You can still
other
change
areas.
people's life.
You can still have an impact on people through technology.
Why is STEM education important? Why do you think?
Not only does it explain things to people or to us, it also teaches us to be data-driven, evidence-based. This is very important. Not to undermine or underestimate the importance of intuition, which comes with experience and so on. But it is one thing to make a decision because it looks right? And it's another thing when you make a decision because the evidence and the data show that this is the right direction. And it gives you predictability in a sense. It gives you clarity. It gives you visibility into what's to come or how to handle what's to come. It even identifies what will be unclear. You know what I mean? So as you go through a path, and because the data and science, it tells you that this is the right thing, but then they also tell you that somewhere along there will be an area that not clear. We don't have enough data for it, which gives you, you know, a milestone or a gateway where you say, let's revisit the data again to see to do the disambiguation.
Okay. So you mentioned intuition, and that brings me to mind Steve Jobs, who famously went with intuition, and you worked with him. But he was...
I worked
for his company.
For his company, yes.
But he was not a science graduate.
That's
he was
true.
You know, he was a college dropout, and he went to read and study typefaces.
Yes.
So how do you reconcile STEM with somebody like Steve Jobs? Is science and math important for somebody to enter the tech industry?
No. It is, you know, oblivion to science and technology, you know, of course, will not work, right? But being aware of science and technology and what science can do and what, definitely. But in fact, I would argue that a lot of innovation happens when people from different backgrounds, like liberal arts and some, join the technology, because it's diversity of views. Nothing is simple, so they bring in a new angle, right? The science and the technology and all that make it happen, but finding the angle. So with Steve Jobs, he's like the ultimate visionary, right? So he had a vision, and he had enough education to tell him that that vision can happen.
What did you learn from working at Apple?
Oh God, I learned a lot of things. I learned solid software development. I learned the importance of specialization, the importance of focus, the importance of accountability, the importance of never taking yourself seriously, right? I learned what great management is. I also learned what really bad management is. So
you learned all of that.
I learned all of that, and I'm forever grateful that I had that opportunity.
What advice would you give to somebody who wants to join the tech industry? What skills should they be learning?
First off, it is never too late. Okay, never think that you're too old or too young for that matter. Second thing is there is now like an abundance of tutorials, and don't be afraid. Your computer, unless you spill a glass of water on it, nothing's going to happen to it. You're not going to ruin it. And if you're already in technology, don't be aware of complacency. You have to be updating your technology stack all the time. You have to do it either as part of the job if it makes business sense, or on your own time. But always understand that things are changing and that you need to be aware, at least aware of the changes.
Nancy, thank you so much for your time. Thank you for stopping by and talking to us.
Thank you. It's a pleasure. Thank you for having me.
And thank you for watching. If you missed any of our shows, you can watch them on our YouTube channel. We'll be back again with another edition of our show. Until then, goodbye.
This series on women in science, technology, and business is brought to you by Zoho Corporation. Zoho is the operating system for business.